Sathyabama Institute of Science and Technology.
Have a good day. This is Triveni from Department of CSE, Sathyabama Institute of Science and Technology, deemed to be university. In today's lecture, we are going to see about normalization in database management system. Usually, we'll store data in database management system, and we'll see how we store data and how we normalize the given table. So these are the contents we are going to see today. So the first one is what is normalization and why are we using normalization in our given tables. And next is data anomalies. And next we are going to see about the normal forms, first normal form, second normal form, third normal form, and Boyce-Codd normal form. We are going to see about the normalization. Why are we using normalization? In database management system, we have a huge number of tables. So we have to reduce the data which are in redundant data, and we have duplicate data as well. So in order to reduce the space and in order to make the performance better, we are using normalization. So redundancy data are nothing but we have multiple copies in the data, but it is not identical copies. And duplicate data are nothing but we have multiple copies with the identical copies. So these are data anomalies. Data anomalies are nothing but normalization came into an existence because of this data anomalies. Data anomalies are nothing but it is a sudden task or sudden performance which cause errors and inconsistencies from our table. So we have three types of data anomalies here: insertion data anomaly, deletion data anomalies, and updation data anomalies. We are going to say about the data anomalies here. So the first one is insertion data anomaly. Insertion data anomaly is nothing but if we add a new data into the database without having the relevant data. For example, if any new employee joins into a firm but it is not specified of his work department. So if you want to add that data into a database without any given work department, so it causes a data anomaly. So without the work department, those spaces will be null. So next is updation. So if you are updating in one place, for example, if you are changing address in one place, but if you are not updating the same address in all the relevant fields, which cause data error again. So next is deletion data. The tables are interconnected, and if we have two different tables merged into a single table, so if we delete the data's customer, if we, for example, if we delete the customer's data, automatically the product data would be deleted. So that's why we have to avoid this deletion data anomaly. In next stage of normalization, we have different normal forms. We are going to see about the major normal forms and used in normalization. So we have 1NF, which is also known as first normal form, second normal form, third normal form, and Boyce-Codd normal form. We are going to see about the first normal form. The first normal form should contain only atomic values. Atomic values are nothing but the unique values. So a single table should contain only the unique values. Only then it is considered to be in a first normal form. And the second condition is it violates when it has multi-valued attributes. So we should not have multi-value attributes in the first normal form. And this is a given example. So I have a relation here called department. So I have three different columns. So the first one is department number, department name, and department location. So we have two different departments and two different names, and we have three different locations in a single department number. So as I said, it violates the rule. So we should not have multi-valued attributes. We should have only atomic values. In order to overcome this error, we are going to see about two solutions. So this is the first solution. We are forming a new different table. The table name is department new, and here we are just splitting the three values in three different columns, but it occupies more space. So again, in order to reduce this error, we are finding the new solution, solution 2. So here the table name is department new 2. So here again we have department number, department name, and department location. If we have single value in a single department, so we are only specifying that location. If we have three different locations, we are just specifying it in each single row. In this way we can save more memory space, and it also has the optimal solution, and it satisfies the first normal form. And we are going to see about the second normal form, which is also known as 2NF. So if a table is said to be in a 2NF, first it need to satisfy the first normal form. So it must be in the first normal form, and the most important thing is it should not have any dependencies. It should not have any partial dependencies. So and the second point is if 2NF has any partial dependencies, we have to split the tables. So let's see how we are going to split the tables. So this is the given example. We have SSN. SSN is nothing but your register number or serial number. We have project number, project name, project description, and project location. So here we have functional dependencies. So we have two types of functional dependencies. The first functional dependencies is we are selecting this SSN as SSN and project number. So register number and project number will be our primary key, and the non-key attributes are project name, project description, and project location. So here we have two types of functional dependencies. The first one is SSN and project number is a primary key, and project name is dependent on both SSN and both project number. And the next functional dependency is project description, and project location is dependent on SSN number. So in order to overcome this, we are going to find the optimal solution for second normal form. In the first table, we have just split the second functional dependencies, that is project name is only dependent on SSN. So it is not dependent on any other columns. Here only the project name is dependent on SSN. And in table 2, we have splitted the table according to the project location, project description, and project name. Here the composite primary key is project name. So the non-key attributes are project description and project location. So the project location and project description is dependent on only project name. So in this way the second normal form is satisfied, and we obtain the optimal solution for second normal form. We are going to say about the third normal form. Third normal form must be in a second normal form. It should first satisfy the second normal form. And the third major thing is we should not have any transitive dependent data in a third normal form. So transitive dependencies are nothing but here we have department number, which is dependent on SSN number. Again we have department name, which is dependent on department number. So like this, if this is A, this is B, and this is C, B is relying on A and C is relying on B. So obviously C is independently relying on SSN number. So how we will overcome this method? So again we have table SSN, name, DOB, address, department number, and department name. Here the composite key is SSN. So this is also a primary key. Again we have two types of functional dependencies here. The first functional dependency is the non-key attributes are name, DOB, address, and department number, which is automatically dependent on SSN. And in the second functional dependencies, the department name is dependent on department number. It is not dependent on any other table. So here we are finding the optimal solution. So the first solution is we are just splitting the table into two. So the first one is department number, address, DOB, and name is dependent on SSN, and in the second relation only the department name is dependent on department number. So next is Boyce Codd normal form. Boyce Codd normal form is an advanced version of 3NF. So we can also say that it strictly follows the 3NF. So here the difference is every BCNF in every functional dependencies X to Y, and X must be a super key. So here LHS always should be a super key. So for example we have three different columns. Here we have student, teacher, and subject. So here we have three types of functional dependencies. The first functional dependency is student and teacher is dependent on the subject. Okay, so the subject is always related to the student and teacher. And the second functional dependency is the teacher is also related to student and subject. And the third functional dependency is the subject, always the teacher chooses the subject and student also chooses the subject. So how we'll overcome this error? So we are finding the two different relation tables. So the first one is we are relating the subject to the teacher. So what happens here is we have different subjects and we have different teachers. So teacher Ria will handle DBMS, teacher Raj will handle ASP, and teacher Z will handle ABC. So again, in this second relation we have student to teacher relation. So whereas here only the student and teachers are interconnected. So here we have student X is also related to Ria teacher, and also student X is related to Raj teacher, and we have Y, student Y is also related to Ria teacher, and student Y is also related to Z. So this is a continuation of Boyce Codd normal form. Here in the first relation, as we said, we need to satisfy the 3NF, but in order to satisfy the 3NF, we should not have any transitive dependencies on composite primary key. So here we have a previous example. Here the student Y is related to Z, and here the teacher Z is related to the subject ABC. So this is automatically transitively dependent. In order to remove this, first we have to solve this. So here if we try to delete student Y, we will use the information that Z is also teaching ABC. So if we are trying to delete Y, then automatically Z is related to subject ABC. So in this way we can avoid the transitive dependencies and it satisfies the third normal form. So automatically it will be satisfying the Boyce Codd normal form. Thank you.